Everybody hear me?
Yes.
Okay, cool. So, first of all, let me just get a little thing right there. All right, so let's just start. So good morning, and thank you everyone for joining us in the Advanced Electronics session. My name is Terry Klass with Empire State Development's Division of Science, Technology, and Innovation, known as NYSTAR. I'll be your moderator for the next 50 minutes or so. And we have a very impressive lineup in our panelists today, and I'm looking forward to a productive and exciting discussion. This session is part of the NYSTAR Innovation Asset Showcase, which is focused on a number of different high technology clusters and highlighting key capabilities and innovations in New York State, with a focus on how companies can leverage the robust R&D ecosystem supported by NYSTAR. Advanced electronics and microelectronics are, of course, a foundation of advancements in all kinds of industries. In fact, I challenge anyone, the attendees or panelists, to get through the day not using one of these advanced electronics that we absolutely need now. But anyway, the key innovations in this sector are those that are engineering novel solutions and materials that enable ever faster transmissions and processing of information and ever more energy efficient electronic systems. So in my personal was lighter, faster, cheaper, smaller. And I think that's still the mantra for today. And because of that, the state began investing long ago in a big way, which I think some of the stats that you saw before this illustrated, in semiconductor and nanoelectronics technology, exemplified through what is now known as SUNYPoly Tech, which is represented on our panel today, and also through Binghamton University, where multiple NYSTAR supported centers fall under the S3IP umbrella, which is the Center for Excellence in Small Scale Systems Integration and Packaging. I always love the word packaging. You know, it's not packaging of cereal and it's not packaging of Amazon. It's packaging of assembly of microelectronics. I never did warm up to that term, but nonetheless, it is the term the industry uses. And we also have the private sector represented by Gluconics, which is a part of the lab, a lab in SUNYPoly. And before we get this discussion rolling, I just want to briefly do some housekeeping stuff. So if you have any questions for the panelists or myself, please use the Q&A function. You'll find at the bottom of your screen, I hope. Your mics will be muted and the chat is disabled. So please remember to use the Q&A function. So now for our subject matter panelists, I'll just introduce very briefly. First, we have Shahedipour-Sandvik, who is a PhD and director at the Center of Excellence in Nanoelectronics and Nanotechnology. Karen Torrejon, who is a PhD, I hope I said that right, and founder and chief science officer at Gluconics. I hope I'm saying that company right. And then Bahgat Sammakia, who's the vice president of research and development at Binghamton University and the lead at the S3IP Center. So with that, I would like each of our panelists, one, to test that your mics and everyone can hear you, and maybe just do the Reader's Digest version of, you know, what you basically do and who you are, and then I'll start with the questions. So Bahgat, if you don't mind, you draw the short straw. We'll start with you.
So before I start, I'd like to thank ESD and NYSTAR for holding this event today and for inviting me to participate. I think it's really a great opportunity to get academia, industry, and government together to talk about things that matter to all of us. My name is Bahgat Sammakia. I'm the Vice President of Research at Binghamton University. And I also direct one of New York State Centers of Excellence, S3IP, which is the quote-unquote packaging center at Binghamton. I should also mention that I've spent all of my career in New York State. So first I was with IBM for about 15 years, and then I joined the university about 20 years ago. And it's a real pleasure to be here today.
Thank you, Bahgat. Karen, how about you?
Hi, good morning. I'm Karen Torrejon and Torrejon, either way, depending on how you want to make it sound. I'm okay with it. And I'm, as Terry mentioned, I'm the CSO at Glauconics Biosciences. And we really are in the business of providing 3D tissue models that are going to help accelerate drug development and also the next wave of novel personalized medicine as well. So that's and as Terry said, we are located at SUNYPoly. So hopefully we'll talk a little bit more about that during the discussion.
Thank you, Karen. Shadi, your turn.
Good morning. First of all, before I start, I wanted to echo what Bahgat said. We are grateful for this platform to basically present what's really important to us, but also to ESD and Fuse Hub, everybody that has come together to bring industry, academia, and government together to discuss these very important topics. And NISTAR has been such a fantastic partner. So I wanted to give a shout out for everything that they do on behalf of development, economic development across New York State, specifically through these centers that are just really important as an economic engine for the state. So my name is Shahedipour-Sandvik. I am the Vice President for Research and Graduate Studies at SUNYPoly. I'm also the Director of Center of Excellence here at SUNYPoly for nanotechnology and nanoelectronics. I've spent pretty much all of my life in academia. I'm your typical academic, but I have the privilege of working in a place that is co-located with a large number of companies. So it is just in our DNA to interact with industry and really try to understand what's important to industry and for job creation, all of that. Before I end my introduction, I wanted to acknowledge everybody at SUNYPoly that contributes to both of our centers, our CATs and COEs. But in particular, I want to give a shout out to Mike Fancher, who is the director of our CAT, and also Ross Goodman, who's the deputy director for both of our centers. They're extremely committed to our companies, to the growth of our companies, to the mission of the centers. So everything that I will talk about today is really their work. So thank you, Terry.
All right, thank you. And thank you, all three of you panelists today. And I owe you $20 each for that plug for NISTAR, and I'll get that right to you. So let me just start with some questions. And Bahgat, again, drawing the short straw. First of all, you know, Binghamton University and the S3IP are known for advanced electronics like nothing else in the country. I mean, it is a most impressive facility and capability. But I'm interested in what are the hurdles that you're trying to help overcome in this field, and what are the outcomes that this will have for products that are powered by advanced electronics?
Yeah, that's a great question. So before I talk about the hurdles, I think, let me say a few words about the opportunity, because the hurdles arise because of the opportunity. So electronic systems, chips in particular, have been shrinking in size. So the transistors on a chip are increasing in number and shrinking in size very significantly every year. We're now down to a few nanometers in terms of the size of a single transistor. I believe that 7 nanometers is in production in some places, and the next generation will be 5, and then the one after that will probably be 3 nanometers. And just to put that, to let you imagine it, I have a presentation in which I show a picture of a virus, and it's covered by thousands of transistors. So that gives you an idea about how small the transistors are. So a typical chip today would have billions of transistors on it. This is great news because it means we can have very fast chips that can do tremendous work in a very small space. But it's also a problem because those chips have so many transistors. If you power them all at once, the chip will certainly overheat. So we're forced to run multiple cores simultaneously and move the workload around from location to location on different chips and even within the same chip. That's just so we can keep the chips from failing and running at a relatively cool temperature. So why are we doing this? Well, if you think about the advances in hardware, there has also been very significant advances in software. what's happening in the field of AI and data analytics and big data today is really transformative. So over the next few years, everything is going to change. So every single field of human endeavor will have AI systems in it and will work better. Engineers and poets and musicians will all be using AI to optimize their work. And all this comes, of course, at a price, as I mentioned earlier. So the shrinking transistors, the crowded chips, the high temperatures are all hurdles that are covered in the packaging side. So what has emerged out of this is a new approach, which is called heterogeneous integration. This is something that has been done in the past, but it's really different in the current technologies. So chips made by manufacturers from all over the world are being brought together into single packages to create a system. So the system could be the Fitbit around your arm, or it could be your laptop or your mobile phone or a supercomputer. All of these systems have chips from all over the world integrated very closely to work like a single monolithic device. And that's really a major challenge. From a thermal perspective, it's a challenge. From a reliability perspective, assembly and manufacturing, all of these are significant challenges. So SUNY, including Binghamton University and Poly and Buffalo, in collaboration with Purdue, have started a new center. It's a national, actually it's an international center funded by all the chip manufacturers around the world, or most of the chip manufacturers around the world. And that center is focused exclusively on heterogeneous integration and packaging challenges. So that is one of the most exciting research areas for us right now. And it's forcing us to look at very advanced technologies in terms of packaging and thermal management and reliability. So I think that given these challenges, the opportunity here is not to try and compete in these pre-competitive areas, solving these problems. The opportunity is to bring industry together, just like Shadi said, with academia and also with government, and to invest and to establish the new technologies that will really change the way we live in wonderful ways. And I'll leave it at that, Terry. Thank you.
All right. No, great. Thank you. And I'll have a follow-up question right now, Bahgat, and that is,
okay.
You know, your career with IBM and academia, you know, you and I are both have been around the block a couple times now. But tell me, and for the audience, how can companies leverage the expertise and the facilities at Binghamton and at your center? How would it best serve a company to contact you and get that, you know, that information and that technology that you're developing?
Oh, thank you for that question. I think that's really an important point. So at Binghamton, we have 3 ESD and NISTAR centers. We have a Center of Excellence, and underneath that, we have 2 centers of advanced technology. Both of them are New York State centers. One of them is focused on electronics packaging and reliability, and the other is focused on flexible electronics. All centers are really designed to work with industry. I mean, that's really every single center almost exclusively works with industry on all the projects that we do. The great thing about that is that it means the work is relevant, that it will have an impact on society, and that somebody's waiting for the results of this research. And the other great advantage is that when you work with industry, you have better opportunities to get federal funding as well. So we are able, in many cases, we get major federal funding, which increases the workload that can be done with the funds that we get from New York State and from industry. So that's really the ideal way to work. At Binghamton, at any time, we have 200 to 300 active contracts working with industry. So it's something we know how to do, and we really love working with industry. These companies could be small startup companies to middle-sized companies, to companies like IBM, GE, Corning, Apple, Microsoft, NVIDIA, and Xilinx are all actively working with Binghamton right now through these centers. And the best thing that we can do is that when we collaborate with the COE and the CAT, we establish infrastructure. And by that, I mean people and instruments and equipment. And this allows us to help the entire spectrum of companies, all the way from the startups up to the global multinational companies. The best way for industry to work with us is to approach us and tell us what they're trying to accomplish. And based on their needs and their size, we will work with them. We develop the right contract, the right way, and we're willing to work with them. In some cases, we're willing to do the work and not charge the company at all if it's something that's important and makes sense and the company just can't afford to spend the money. But the best relationships are with companies. And this is really one of the key things about working with industry. The best relationships are when the company is very demanding, has very specific needs, and puts mentors on every project that want results and that talk to us on a weekly basis to get updates and keep us focused on what they need rather than just interesting research. These companies also serve on our advisory boards, technical advisory boards and departmental, and they work on college advisory boards as well. They have a presence on campus. They come often and use the labs and work with our engineers and scientists. So all these things matter. And that's really how industry can approach us. They can just come and meet with us, and we will develop the right approach to work with them, regardless of size and regardless of whether it's basic research or very applied research. We're here to serve industry.
All right. Thank you, Bahgat. And for all the attendees here, I would encourage you to reach out to Bahgat. They have just a national resource in terms of advancement in electronics and microelectronics assembly. And so if you have a product or a service that you're looking for, lighter, faster, cheaper, smaller, I would point you to Bahgat. He's just an impressive facility and capability. All right, let me shift a little bit here. And Karen, I'll start, or second, you're up, and that's Gluconics is in the business of drug development, correct, for the eye. And can you tell us why you're located, the lab is at SUNYPoly Tech and the Institute in Albany?
Sure. First of all, Bahgat, I really enjoy your discussion, and I'm going to be contacting you because
Wonderful.
there is a lot of synergy, I think. But anyways, yes, we are located at SUNYPoly, and well, and why did I locate it here? Mainly, I'm actually a former grad student here. So I got my PhD here. I was able to know firsthand, right, working how the university works, working with the faculty, being able to get to know them, really understand the expertise that they have. And I think being able to be mentored by a multidisciplinary, group of professors, engineers, and even doctors really influenced me and made me want to stay here. We already knew the capabilities that SUNYPoly had. We understood basically the ins and outs in a way. How can we leverage, again, talking to Ross and Michael Fancher, how can we work with the university to try to make the best out of the technologies that we are developing? And a lot of the times people think because we are in the drug development side, that there might not be a direct connection, right, with semiconductor or packaging or manufacturing of electronics, but there is actually a lot. They go hand on hand, especially for our technology. For those of you who do not know, actually the basis for our 3D tissue technology, our patented technology that we actually licensed from SUNYPoly, it's really based on semiconductor lithography techniques, right? We actually developed it here using the clean rooms here at SUNYPoly. And once we were able to scale up that technology, we then decided to spin out, seeing that there was interest from industry to have us use that technology to screen compounds. And that's exactly what we did. And we just thought it was the natural way to stay here. We have the clean room facilities that we're able to use. But something else that it's been extremely helpful for us, and I think we don't talk about this enough, is also the workforce, right? The students here at SUNYPoly, and I'm sure it's the same thing at SUNY Binghamton, they really have a cutting edge uh, um, learning capabilities, right? Our professors are really out there in the field. They are the top of developing the major technologies, um, major breakthroughs that are happening right now. So they are actually seeing a lot of this. Their mentality is it's much different than those who have been in the field for so long. So they come into our labs and they actually bring all this knowledge, all these ideas into our laboratory, and it's been great. I mean, actually, people that we have employed. We have several employees. Many of them decided to stay with us after graduation. Some of them decided to go and get their PhD, and it's really great to be able to then hear back from them and telling us that because of the opportunity they had at Glauconics, they were able to, decide that they wanted to go into getting a higher degree, getting their PhD, and just overall that the workforce, having those students, having that those postdocs that have that knowledge, and also we have hired several of the postdocs from SUNYPoly into Glauconics because they just have been exposed to, again, a multidisciplinary view of science, and that's really why we ended up staying here. I mean, I think we have a relationship not only from being able to utilize a lot of the facilities here, but also collaborate with faculty. Again, the students and postdocs that come out of here, I think are superb and have worked very great for us.
So it's interesting you did bring up workforce development, and SUNYPoly, is a pillar in the nation. I visited the facility many times before our COVID, and it's just an incredible facility in the semiconductor world and advanced electronics. You touched on this, Karen, but maybe just to give our audience a little bit more of how does the advanced electronics help to contribute to the product development in medicine for your business?
Sure. So I'll give you an example, and I think our flagship model, or our flagship technology, it's really within the area of ophthalmology, specifically glaucoma, hence our name Glauconics. We are now branching out into other areas as well, so we may have to change our name or create a different entity, but our flagship model had been within glaucoma. And for those of you who are not familiar with glaucoma, glaucoma is a neurodegenerative disease that the only way that you can currently prevent it or treat it is really to lower intraocular pressure. So essentially, our eyes are constantly wet, right? If you would, many don't realize, but there's a constant flow of liquid that's going around our eyes. If there is some kind of blockage that does not allow the aqueous humor or the liquid in the eye to pass through normally, pressure starts being elevated in the eye, which then ends up damaging the optic nerve, leading to irreversible blindness. So that's the other scary part about glaucoma. If you don't treat that elevated pressure, that sight that you're losing, you would not be able to get it back as of right now. So it's something that it's very important for the field, and current models have not been able to really study novel drugs or therapies, and even at the gene level for treatments for glaucoma. So being able to measure pressure changes, it's key, and especially in the eye, and when we're working with really small cell level tissues, right? We want to be able to measure very small changes in pressure. And for that, you definitely need electronics, right? You need to use advanced electronics. We worked for many years on trying to develop specific sensors that would able to specifically and reliably measure those small pressure changes. And that's just one example, right? There's a lot of technologies nowadays. Can there be a technology almost like a contact lens? And I know there is, because there is a couple of companies working on that as well, where you can actually monitor that pressure change so you can prevent glaucoma or vision loss before this happens. And I mean, it's really like you said earlier, it's really all around us, right? Even most of us are using Fitbits. We're using all sorts of different sensors now with the self-driven cars, right? That's also part of sensors and advanced electronics. So really managing all of these technologies and really accelerating the development and the studies in this field are really going to make huge breakthroughs that are needed as we're moving forward into newer territories of medicine, personalized medicine, into self-driven cars, even all sorts of different aspects of our lives. So I hope that answered your question.
It did. It did. No, thank you. Thank you.
Okay.
Because it doesn't jump out, how the iMedicine and advanced electronics might connect, but you nailed it. So thank you so much. Shadi, a little bit, Karen just spoke about her company's medical innovations and with the advancement of electronics that we all four of us here know is affecting us every day. Can you give us examples of other industries that SUNYPoly is in their R&D efforts are impacting?
Oh, absolutely. Okay, I had muted myself so that I wouldn't. I would say really the way that SUNYPoly, both our COE and CAT, engage with companies has been engaging in the past couple of decades. It's really both vertical and horizontal. So in a sense, vertical is more intuitive, vertical collaboration, and this includes company partnerships, partnership with these companies that constitute this supply chain for digital manufacturing. These include computer chip manufacturers such as GF and IBM and Samsung, to equipment suppliers such as AMAT, TEL, Lam, to ancillary equipment suppliers such as Edwards Vacuum, MKS, Infocon, to chemical suppliers such as Air Liquide. So we kind of think about how all of this ecosystem really need each other, and they kind of build on each other's technology. So we have been collaborating both vertically and interacting with these companies, but we also do horizontal collaboration, and these are adjacent industries where these nanoscale and know-how that we have developed during this past couple of decades, and especially taking advantage of what our COE and CAD offers, we can offer these to these small adjacent companies, startup companies in particular, that can use these know-how for their explosive growth. And a great example of that is actually glauconics. That's adjacent industry that we don't think about it. It's not, if you kind of think about SUNYPoly, COE, and CAD, that they are very focused on nanoelectronics and nanotechnology, you wouldn't think a biomanufacturer like glauconics, but that's the type of adjacent industries that really benefit from these know-how that we have developed. Other application areas are, for example, clean energy manufacturers, fuel cell, PV, power electronics, biosensing, and power electronics is also a really good example that you don't necessarily, when you think microelectronics or nanoelectronics, you don't think about it, but it's extremely important and continues to be very important. So Terry, you're absolutely correct that there is no limit to the industries that can be impacted by these advanced electronics, and by I would say by extension of that advanced manufacturing. So just to give you just some examples of these companies that we have recently interacted with, equipment manufacturers such as AMAT, very close collaboration, Lam, TEL, we have very close collaboration with these companies, to information technology companies such as IBM, or IC manufacturers such as GF. And I give you a really good example also is optoelectronics companies, such as Marktech Optoelectronics, that we have very good collaboration, and our CAT benefits them, and hopefully they do see this benefit in their growth. And NextGen, which is again upstate New York, that we have had in power electronics, we have had collaboration with. So I would say it really goes the gamut of both vertical and horizontal. So I'm happy. I mean, there are just so many examples. I'm happy to get into details, but I'll leave it at that.
Well, let me lead the witness a little bit on this next question for you, Shadi, because the industry, semiconductor and advanced electronics, is I think you'd all agree, it's kind of a capital intensive kind of endeavor. And many, you know, companies just, if you're IBM and your GE and your Apple and you pick your favorite, they have the financial resources to leverage or to develop their own type of capabilities in-house. So this is the leading the witness question. So what type of companies can benefit from SUNYPoly, their facilities and expertise, other than, I'll say the big five, right?
Absolutely. Absolutely. And I would say really generally the type of companies that can benefit from our NYSTAR funded centers and SUNYPoly in general, they really run the gamut. And that's because we have positioned ourselves to really cover the entire RD&D, research, development, and deployment. So you brought up the big five. The big five can take advantage of our actually center of excellence because they have, as you said, they do have the resources, and they may not necessarily think about them as needing an academia or these centers to help in their growth. I would say that's actually incorrect because we have a large number of collaboration with the big five, or I don't know if big five is all of the big five, but a subset of that big five that take advantage of these. They still need access to know-how. They still need to, some of them, they need access in order to go to prototyping and large scale. They require access to manufacturing compliant industry facilities, which, as you know, SUNYPoly offers, and through our centers, we can provide access to them at a fraction of the cost that would cost them because of all those equipments that are involved. But I would say companies that are in early stage growth, startup companies that they need access to more basic R&D, they would benefit a great deal by what our CAD offers in terms of access to from business case development to proposal preparation to advocacy to access to know-how, metrology. There is really a large list of benefits that, regardless of the size of the company, can benefit from both of our centers. Again, there's so much I can say because I'm so excited about what we really offer. And our faculty, I want to mention something because I think it's really important. When we talk about COE and CAD, people could have this idea that these are separate entities within a university. At SUNYPoly, that's actually not the case. It's almost like distributed across the college. You have faculty that are your normal faculty and doing their own teaching and research, but they actually are part of the center and they are collaborating with companies through what our centers offer. So I would say, regardless of the size of company that folks have and the audience, if you have a need in nanoelectronics, microelectronics, power electronics, and everything that comes around it, I think SUNYPoly could offer a great deal.
Awesome, thank you so much. And I could not agree more, having been there. And you know, Karen had a benefit of getting her PhD there, so she sort of gets to leverage the people and the resources just through osmosis of being there. But for small and medium-sized companies, I encourage all of you that are listening and watching to, if you really want to understand nano materials, nanoelectronics, advanced electronics, SUNYPoly is, again, one of those pillars in the nation where I just don't think you can go down the road and find the other resources like that. So thank you. Going to shift a little bit back to Bahgat, and you know, Binghamton and it, again, just has an incredible capability in advanced electronics. And you've talked about the shrinkage of transistors in your earlier comments. Tell me a little bit about, or the audience, a little about flexible electronics. I think that's always an interesting field, at least to me, how you can take a polyimide or other materials and create circuits that form into the product. So I'll let you describe how that works and the advantages of flexible electronics.
Thanks, Teddy. That's a really great question. So there are You can think of flexible electronics as two things. One of them is electronics which are flexible and on their own. So they're basically everything is a polymer or a plastic or a sheet of glass. And they're flexible and you print the electronics directly on them. This is very challenging, especially when you're talking about transistors. So active transistors are really difficult to manufacture on a technology like that. But it's possible. The other alternative, which is the clever way of doing it, is to have flexible hybrid electronics, where you take silicon devices, which could be very small, but very, very highly functional, and then assemble them on a flexible substrate. So you take very inexpensive plastic and you process it and you create locations where you can attach silicon directly to that flexible substrate. So what are the advantages of doing that? Well, one of the advantages is that you can, now you can create electronics on conformable materials. So you can make a suit out of it. You can make something that a person can wear, or you can wrap it around the structure. Or you can also create it in very large areas. So we, in our manufacturing line at Binghamton, is a roll-to-roll flexible electronics line. It's run by Mark Pollux, who's the director of the center. And that line can create sheets which are up to 200 meters long and about a meter wide. And that could be all a functional hybrid electronic structure. Or you can make small pieces. So you can imagine the cost also becomes extremely low when you build things on such a large area compared to silicon wafers. So the advantages allow this to be used in many of the areas that Shadi and Karen were talking about. So you can create electronics which are like the human body, flexible and conformable, that can be wrapped and turned. You can also make them of any shape or size that you want. And you can also start to work on applications which are very sensitive to weight, like aircraft and rockets and anything, any applications in space. In the area of health sciences, obviously, there are a lot of advantages. In areas like energy, you can now create solar harvesters that can be launched into space. They're lightweight and very large in area. Yeah, so cost is a big advantage, and some very specific applications like healthcare and health monitoring, medication delivery, sensing. You can make sensors that are at an incredibly low cost when you create them by the million on a single sheet of plastic. The applications also go into smart energy, communications, and heterogeneous integration, which I had talked about earlier. So this is like a brief overview. Anyone who wants to learn more about any of this can contact either me or Mark Pollux directly. You can find the center online. You can there's an extensive web page that you can look at there, and then contact either one of us, and we'll be happy to work with you.
So we do have a question from our audience. It's sort of a two-part question, and I wasn't sure when it came in or who it was directed for, but based on the question, I think it's a Bahgat and Shadi type of question. So I'll ask you both. And Bahgat, you just sort of answered the first part, which is what is the best way to engage with these programs? And the second part to the question is, which is a tougher one, is what's the timeline a company should expect when working with these programs, right? So Shadi, I'll shift to you first, if you don't mind, in the best way to engage with the programs that SUNYPoly can offer, and what's a timeline that a company might expect to, in working with these programs.
Absolutely, and I actually put my email in the Q&A for whoever had the question. As Bahgat said, the best way to connect with us, I would say Michael Fancher or Ross Goodman, but they are not here, so I'm going to say contact me. And I put it in the Q&A, and I'm happy to, I don't see the chat feature, but contact me or mfancher@sunypoly.edu or rgoodman@sunypoly.edu. And we are happy to set up a time to talk to. They are extremely active. They will get on the phone and connect with them. And we can discuss timeline and whether we can help. If we can't help, there is a really good possibility that we can help. We do such a large range of interaction and collaboration, we can help. But if we can't, our goal is really to make sure that our company partners are successful. We will refer them, we will connect them with other COEs and CATs. We also have a very good website. Definitely check out our website, but probably maybe the easiest way is get in touch with me and we'll discuss that. In terms of timeline, it really depends on where they are within that continuum and what they are trying to achieve. It could be from a couple of weeks, depending on what it is that's needed. Sometimes people really just need to deposit a dielectric, and that's all they need. They are creating an acoustic wave sensor or something, and that's like one layer of deposition, one litho stage. So it can be just a couple of weeks, or it could be a multi-year interaction. We are flexible, but we need to understand what the problem is that the company is interested to solve.
Understood. And you know, the great thing about the COEs and the CATs is if you do call, you rarely get an answer that says, no, we don't work on that. Thank you. Goodbye. You know, they'll help and point you to where a center across the state or across the country. So again, for the attendees, our centers of excellence and our centers of advanced technologies are staffed with outstanding subject matter experts that are humans as well. So they'll help you no matter what your question is. Bahgat, a little bit, you've talked, you answered the first part in terms of how to engage, but the timeline, does Binghamton have sort of segmented by projects or by categories of technologies, or how does a company fit into that timeline of what they're interested in?
So yeah, I mean, we really work with industry in many different ways. The shortest timeline would be a company that has a problem that requires an instant answer, and all they need is some diagnostics testing and sleuthing. And that could be even one day. I mean, they can come in with a sample and say, the surface is failing. Can you look at it and tell us why? And we have all kinds of diagnostic equipment. And more importantly, we have staff with extensive experience in industry that can very quickly respond. I mean, again, we have contracts which are designed for that. The person can come in with the sample, sign a joint NDA, and we can immediately test the part and let them know what's going on. More typically though, we like to have longer term partnerships with industry when it makes sense for both sides. So for those, we like pooled research where a number of companies work together and support a topic that is of common interest. So we do it both ways, but you know, I think Shadi gave the perfect answer. We want companies to succeed, so we will do whatever it takes to solve their issue, and then we may think about things that as outsiders we see that they might be unable to see, and we love when that happens as well. So both ways we're delighted to work with them.
Okay, thank you.
And I think that Mike Fancher is online, and so is Goodman, I believe. And Benson Chan from Binghamton is also online. Benson would be another excellent entry point to Binghamton University. He works in one of our CATs.
Sorry, I do know Mike and I do know Benson, and they are resources and points of contact for anyone that's listening and watching today. So
absolutely,
they're just great people. Karen, just back to you briefly. You know, it's always interesting for a product development type company in leveraging any of the NISTAR assets, right? So can you give an example maybe of how you and your company has leveraged the NISTAR asset across the state?
Yeah, absolutely. So first of all, we work, like I said, with several of the students from SUNYPoly, but we also work on developing newer technologies as well. Like I said, we are working in the glaucoma space. Now we're also working in the back of the eye, so more on other ocular diseases, diabetic retinopathy, but we're also working within the area of pulmonary fibrosis, which is a huge unmet need. I mean, the people that are diagnosed with pulmonary fibrosis usually die within the next 3 or 4 years, and their chances of survival is very, very small. So it's actually and there's no treatments for it. So what we're doing right now is developing newer technologies that are going to help us move. I can't give a lot of details because we're still on the development stage, but really developing technologies that we can scale up to be able to do hundreds of thousands of these tissues, because that's the number that of drugs that are normally developed per compounds that are developed per company for us to screen, and that's just one company. So imagine how many pharmaceutical companies that are trying to develop therapies for these drugs would there really be. So we've worked with, as I say, mainly through SUNYPoly. We've had also discussions with SUNY Stony Brook, and hopefully next we'll have also discussions with SUNY Binghamton, because I think we were there is, especially after hearing Bahgat as well, I think there is a lot of synergy on some of the work that we're doing, especially when it comes to roll, which I know that they are big experts. We are constantly talking to a lot of other SUNYs, actually, SUNY universities. And, I should not forget to mention that really the idea and the unmet need in this area in which Glauconics started working on really came from SUNY Downstate Medical Center, right? When we were talking to them, my background is really in engineering and physics, right? People think I'm a biologist by training, and by no means I'm a biologist. So we talked to people like Dr. John Daniels, who really brought the idea to us, and he's like, you guys are engineers, right? Can you develop something that's human based? You can measure pressure, you can mimic the flow. You guys are engineers. Build something. So, and that's exactly what we did, right? That's exactly what we set out to do. So I think this is why really the whole state, there is a lot of strong universities, a lot of faculty that are really worldwide renowned. And I think just being able to bring these discussions, as we're here, right? Different universities from different fields. I think that's really what's making NISTAR, CAT, and TU, and all the different projects that the state is putting together, really to help bring all this community together. They may not speak the same languages, right? Sometimes physicists don't like to speak with doctors, or chemists don't like to speak with physicists, even though they speak the same language, just a different dialect, right?
Right.
Just bringing them together, because that's really where innovation is going to happen. So I think that the state is doing a really good job in breaking those barriers and kind of bringing them together. At the beginning, yes, you may feel uncomfortable because you may think you don't speak the same language, but the need is there, and you need all the different expertise to be able to solve the problem. So we have moved around in different areas and had discussions with different of the universities and faculties as well from the entire state.
Thank you so much. We have another question from the audience, and it's a good one and not an easy one. But the subject is intellectual property, and how does IP play into your programs? So Shadi, I see you nodding, so I'm going to start with you again. And it's a necessary, well, if you're a startup company and you've got some secret sauce, right, and you're going to go to SUNYPoly and you're either concerned or you co-develop that intellectual property, just tell us how that SUNYPoly handles that.
Yeah, absolutely. And one thing that we are really good at is, because of, as I said, this interaction, co-location with industry is in our DNA. From day one, we had to worry about IP. Right. These companies, where we collaborate with, they do worry about their IPs, and they should worry about their IPs. We are very cognizant of that. And I think this understanding that companies, that's how they grow their IP. They grow their IP portfolio and they go from there. So we have different levels for IP development. It could be a company is very interested to just hold on to their IP and they don't want to share. That's good. We can figure out some lease agreement where the company is actually the time that they are working on an equipment that they have leased. So they have leased that equipment and they can develop their IP and that's their IP. Let's say there's collaboration. whatever that's background IP, it's background IP. They own it. I mean, and the same is for here. If we have background IP, we own it. And then we get into this agreement that whatever that's developed jointly is owned jointly. And we really have this figured out. Again, I'm happy to elaborate because, as you know, Terry, there are just so many versions of this that comes about. And I'm always amazed that there's always another version that comes about, and we think like we have figured it out. So we are very happy to talk about the details of that, and I can provide all these different versions that we can supply. One thing that I would say is that we are really, it's very important for us that IP does not stop a collaboration. We can figure it out.
Right.
We, as Bahgat said, we really look for these long-term collaborations that our company partner benefits from it, but also we are an academic institution at the end of the day, that we have our PhD students working on novel stuff and that they can graduate. So some freedom for academic enterprise, but also making sure that our companies benefit and they get what they want to get out of the collaboration.
Got it. Thank you. So I got a wonderful text that says your time is running out. So anyway, but God, I wanted to give you one second here. Same question in terms of intellectual property and how does Binghamton and your center deal with that?
So I think Shadi's answer really covered it quite well. So basically, like Poly, we are concerned primarily in doing research and working with industry. And we look at IP as a really more of a flexible hurdle that we have to cover with industry very early on. So as long as we know exactly what they want, we'll work with them. So it could be totally confidential. They own all the IP, and there are certain conditions under which we can do that. Or it could be IP follows inventorship. So whoever invents a concept, if it's jointly done, then the IP is owned jointly. And then in the case of consortia, when we have multiple companies, the IP typically belongs to the entire group of companies that have funded the research. We work with all these models. I mean, we have active contacts with all the different approaches. But again, our emphasis is not to try and make money from IP. We want to do research that has a broad and beneficial impact on society and helps New York State's economy and companies. So that's our primary directive, basically.
Well stated. Couldn't be a better mission. Listen, I'm going to tell you, we're sort of out of time. So on behalf of the panel and myself, I hope you enjoyed today's session. Thank you, panelists, for your contributions and sharing your subject matter expertise. For the attendees, if you don't know, this is being recorded and provided in a post-event email, so look out for that. After a quick break, there's 2 more sessions that start, and those links can be found on FuseHub. So with that, again, thank you, the 3 of you. Have a wonderful, wonderful day, and we'll all talk to you very soon. Take care.
Thank you, Terry.
Take care, everybody.
Bye-bye.